Colby, 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 math.com.
The triangle area problems you're working on tonight are presented in groups of 3. The first problem in each group of 3, so problems 1, 4, 7, and 10 are pretty straightforward. You're given one dimension, either the base or the height, and then a relationship to find the other dimension, and then it's just a straightforward process of writing down the area formula. Please do get in the habit of writing it every time you use it, and then substituting the values directly below that, working vertically with any computation off on the side, and then simplifying your area formula to eventually find the area. 2, 5, 8, and 11 in the middle of each of those groups of 3. A bit harder. You still begin by writing the area formula, but you'll be given the area, substitute in for A, and then you'll need to find either B or H in each of those problems. Some of this requires some algebraic reasoning, which, we're doing this ahead of our unit on algebraic reasoning, but that's what it means to be in 6th grade advanced math. There'll be some ideas that you'll sort of work out as you go, and then we'll revisit them in more detail later. There could be an organized guess and check approach if the algebraic approach is, if you find that difficult. And so, a lot of what we did in last night's assignment can apply to this night's assignment. Now, the hardest ones are the third in each group of 3, so problems 3, 6, 9, and 12. And that's why I chose to do 12 on this video. Problem number 12 says the height of the triangle is 1 1/2 times its base, and we're given the area is 27 square feet, but we need to find the base length. So we'll start the same way we would start any of these problems, by writing the area formula for a triangle. Area equals 1/2 multiplied by the base multiplied by the height. And then we'll substitute in the area because we're given the area is 27. That's all we know. Well, we do know a relationship between the base and the height, and that'll be handy later. But first, there's a way to simplify this equation. If 1/2 of this product is 27, then this product must be 54. It must be twice as much as 27. If I'm going to half something and get 27, the something I'm having must be twice as much as 27. So the way we would do this algebraically would be multiply both sides of this equation by 2, because then 2 halves is 1 whole, and by the multiplicative identity we can just factor out that 1 whole. So we get 54 is equal to the base multiplied by the height. Now we're in a position similar to some problems on last night's assignment. We just have to start thinking of bases and heights that will give us an area of 54. And the problem doesn't specify that they're counting numbers or whole numbers, but you can assume that and see how it goes, and then if it turns out that those don't work out, you could figure something else out. But they actually will turn out to be whole numbers in this case. So think about the height is 1 1/2 times the base, so the height is bigger than the base. So start with a small number for B. Think about what H would need to be to make this relationship true, and then see whether that height is 1 1/2 times the base. And if it's not, try another base and height combination that will give you an area of 54, and see if that height is 1 1/2 times as big as the base until you find the height that works. Try that during the pause and come back and see how you did.
Paused.
The smallest whole number that would make sense to use for a base length would be 1, which would mean I would need a height of 54. Well, that's way more than 1 1/2 times the base. If my base was 2, my height would be 27. That's also much more than 1 1/2 times the base. We could have a base of 3 and a height of 18, but then the height would be 6 times as much as the base. 54 is not divisible by 4. 4 is not a factor of 54, so I'm going to skip over 4. And I know 5 also is not a factor of 54, because 54 does not have a 0 or a 5 in the ones digit, in the ones place. We're going to do a lot of number theory later this year. We're going to do a lot of algebraic reasoning. So some of these ideas that you're going to explore in more detail later this year are contained in this problem. Right now we're identifying factors of 54, factor pairs. So 4 doesn't work, 5 doesn't work, 6 works because I could double this factor of 3 and conserve the product by having this factor of 18. 6 times 9 is 54, and 9 is 1 1/2 times as large as 6. Just to prove that, I'll show 1 1/2 times 6 equals 9. You could turn this into a decimal and do 1.5 times 6, but 1 1/2 is just 1 and 1/2. So here's an opportunity to look at distributive property. 1 1/2 sixes is 1/6 and half of 6. Well, 1/6 is 6 and half of 6 is 3. So there's proof that 1 1/2 sixes is 9. And so this is these are the dimensions that will result in all of these relationships being true. But then we have to be careful when we answer, what is the base's length? The base is 6. 6 what? Look at the units, 6 feet. So the answer to the question is 6 feet. Now, I do want to present the algebraic approach to this, even though, I mean, it's not only advanced for this course, but I mean, in the sense that we'll do this later this year, but this is really systems of equations, and so this is pretty advanced even for 6th or 7th grade. But I just want to show you how you would do it. The other relationship that you're given is the height is 1 1/2 times the base. So the height is 3/2 b. That's another relationship you're given. You can substitute that relationship into this equation. So we have 54 is equal to the base multiplied by the height. But if I express the height in terms of the base, so the base times, instead of h, I'll put 3/2 b. And then b times b is b squared. So I get 54 is equal to 3/2 b squared. I can isolate b squared by multiplying by the reciprocal of 3/2, which is 2/3. Because then the 2's cancel, the 3's cancel, and I get 1b squared, which is b squared. But the property of equality tells us we have to do the same thing to both sides of the equation to keep the equation balanced. 2/3 of 54, 1/3 of 54 is 18. You see it right there. So 2/3 would be 2 18s, or 36. So 36 equals b squared. So what must be b? The square root of 36, or 6. Which is the same result we got up here, but just showing you the way you would do it algebraically using substitution and algebraic solution for that. Okay, thanks for watching the video. I'll see you.